2, y is 2. Is that 2? Is it?
All right, so in this, so this question, what you want to look at is the chart is x and y. These are x and y, right? X and y. So the question says f of x is the same as y, right? So the question says the table above gives selected values for the differentiable function. So you know right away this is differentiable. In which of the following intervals must there be, now here's an important question, must there be a number c such that f prime of c equals 2? So must there be a number c such that f prime of c equals 2? Okay? All right, so those of you watching the video, I'm going to give you a chance to kind of take a look at this and see if you can get the answer, and then I'll come back with the answer. So if you want to draw a graph, that's totally fine. I like that idea. So remember, this is x, y. So we've got 0, 8. There's a point. We've got 4, 0. There's a point. We've got 8, 2. 8, 2. There's a point. And we've got 12, 10. So 12, 10. There's a point. And we've got 16, 1. Okay, so 16 and 1. Here's a point. So if we just look at these points, we might guess, and we don't know what happens in between, but we might guess something like this. You might guess something like that. And you think, well, it's increasing. So I think you said it's increasing from 4 to 8. Now, is it also increasing from 8 to 12? Yeah, it's increasing from 8 to 12. So there must be a 2 inside here somewhere. And 4 to 8 is one, 8 and 12 is another one. So maybe this is steeper, so you think that maybe the 2 is in there. Now, it could be possible that there might be something between 4 and 8. But remember, this is a must. So that means that we are looking for some kind of theorem. You're asked about some kind of theorem. And in this case, of course, we've been dealing with the mean value theorem. So what we'd want to do is we want to find out if there is a slope between any 2 points. And these are the 2 sets of points we'd question. Is the slope between those 2 points 2? That's the question. Because if we could prove that there was, that means that because of the mean value theorem, there would have to be a tangent line, right? And this is tangent line. Slope of the tangent line, that would have to be 2. So what you're going to want to do, if you wanted to try between 4 and 8, okay, so the difference in y values is 2 minus 0. The difference in x values is 8 minus 4. So that's 2 over 4. That's 1/2. So the slope here between those 2 points is 1/2. The slope between 8 and 12 now is 10 minus 2 over 12 minus 4, or 12 minus 8. 8 over 4, which is 2. Okay. So between these 2 points right here, this slope is 2. That means that there must be a point between 8 and 12 that also has a derivative equal to the same slope. So C is your correct answer. Okay, so if you guessed C, or if you thought, oh, C is the most likely, that's fine. You get it all correct. It's done. In the short answer, you would have to explain why, and there would be marks for your work. But in the multiple choice, that's good. But I guess I would highlight this, that when it says must, something like that, that means, oh, so I'm looking for some kind of reason or theorem that I can back up on. Okay, so let's see. This is there's a solution here typed out. So yeah, we have a slope of 2 between the secant points connecting x equals 8 and 12. And then therefore, according to MVT, we must have a C that has a derivative also equal to that slope. Those are the same. Okay? All right, here's another one. So take a moment and see if you can work together in groups if you want. Let me just read it for you. Let G be a twice differentiable increasing function. Okay, so when they give you these details, it's usually important. Twice differential means you could take the first or second derivative. So this is valid. See, second derivative. Twice differentiable, you can take the first and second derivative for sure. It's increasing on t. It's an increasing function of t. So t is increasing. It's always moving up. Okay, so being that it's differentiable would mean that it's continuous as well. So it's continuous, it's differentiable, and it's always increasing. From 0 to 10, it's always increasing in some fashion. So go ahead, talk it out. What must be true here? A, B, C, or D? So given this information, you're going to want to use MVT, right? So what do we know about what we're given? Notice these 2 points. That's 0, 20, and 10, 220. What can we figure out from that information? Yeah, we can figure out the slope. The slope of the average rate of change, or the slope between these two, the beginning and end points, right? So what does the MVT theorem tell us? That there must be what? Somewhere on this graph, there has to be a tangent line to some point that has to be equal to the slope of the secant line connecting the endpoints. So if this is a slope of what? 220 minus 20 over 10 minus 0. So the slope is 200 over 10, or 20. B says, on this interval, there must be a value for the derivative at t that equals 20. And by the MVT, I like that one. Now, the second function, or the second derivative, okay, must it be a place where there's 0? Nope. There's, it's positive here in this case. If it's increasing and concave up, it's positive the whole time. Or you could draw it like this, where it's concave down the whole time, still increasing. So it does not have to change from positive to negative, you see? It could be this, it could be this, or it could be this. So that one's out.
What would the second derivative be representing?
Second derivative, if you recall, represents the concavity, right? So this is second derivative is greater than 0, it's concave up. This is second derivative less than 0, it's concave down. And equal to 0 would be the point at which it's neither positive nor negative. So here it's concave up, right? So it's positive here in this region, and then it's negative here. So if it goes from positive to negative, it has to pass this inflection point. Remember the point of inflection? Okay? Point of inflection. So that's where f double prime of x equals 0. So that does not have to be true. And does it have to be true that it's concave up the entire time? No, I just gave you this example where it's concave down. So here, there's nothing that says that we have to have a local max or min. That's what this would say, right? Plus, it's increasing all the time. So there is no point where it goes down again and comes back up. You see, this would be a point where it's decreasing from here to here. So that's obviously not true then as well. So it has to be B. Got it? Awesome. All right, let's do another one. So much fun.
I did that a very weird way.
Oh, did you do it a different way?
Yeah.
What'd you do? Okay, so the other way that Ben did it here in my class was knowing that we have 2 points like this. This straight line would be, what did you say, y equals 20x plus 20, right? We have a slope of 20. We have a y-intercept of 20 right here. And so the derivative of that is 20. Okay, so at some point, if this line, you're saying that the slope of this line is 20. That's just another way of finding the slope of the line, like over here. So, but that's great. That's great. If that's the way your brain works and that's what you want to do, that's great. So that means that the slope of the secant line is 20. You would still have to move from there to MVT. Gives us, because it's continuous and it's differentiable, that MVT would give us some point on the graph where this would also have a tangent line of 20. So yeah, so that's a good way of thinking about it as well. All right, next one. I think I've got 2 more. So here's number 26. Now let's read this. I don't know if they're getting a little tougher. They might be. This one's maybe a little tougher. So it says let f be the function with f of 0 is 1 over pi squared. And again, that's just a number, right? It's kind of like a weird looking number, but it's just a number. So 1 over pi squared is the value, and f of 2 is also 1 over pi squared. And the derivative is given by this equation right here. This is the relation, or the function of the derivative. How many values of x on the open interval 0 to 2 satisfy the conclusion of the mean value theorem for the function of f on the closed interval 0, 2? Okay, you said none right away? All right, you're gonna wanna maybe think about that for a minute, yeah. Yeah, give you a minute, and, yeah, maybe think about that, come up with a reason, discuss with the group. Okay, so, what's your guess? What are your guesses, some guesses?
My guess is 2.
2, so C? Okay, Ben, what did you
I
say?
have no idea. 1.
1, okay, so B, and
Said none.
you said none, A, okay, so we got A, B, and C, okay.
Oh, no. I think I gotta change my answer.
You gotta change your answer, too late, time's up. Time's up, you failed the AP exam, man. No, you can't, I'm just kidding. Okay, let's go over now, if you're thinking something, okay. I tell you what, this is the first thing that jumped out at me right here, was the fact that these two had the exact same value. I don't know what this is, doesn't matter. Pi squared is like a little over 9, close to 10 maybe, so 1/10, right? Something like that. Doesn't matter what the value is, but what matters is that we have this value at 0, and at 2, we have the exact same value. So that brings back mean value theorem, also Rolle's theorem. Remember Rolle's theorem was the kind of a version of mean value where if we had two intercepts, now these aren't intercepts, but they're the exact same value, so they may as well be, that at somewhere, Rolle's theorem says that somewhere in between 2 points that are intercepts, there must be at least one point that has a derivative equal to 0. Why? Because the mean value theorem, it says that the slope of the secant line from beginning to end of the intervals, there has to be a point that has a derivative of the same as the slope of the secant line. Okay, so here, because these two values, let's back this up now, because these two values are the same, that means we have a secant line that is slope equal to 0. Okay, so we're good so far. It does not tell us that this function is differentiable and continuous on the interval. Okay, that's what it doesn't tell us. It gives us endpoints. We don't know if there's an asymptote in here somewhere, right? We really don't know. We also don't know if there's a cusp or corner or something. What we're given is this right here. Okay, so I guess what then you're looking for is are there any values of x, and specifically between 0 and 2, that would make this a discontinuous? So are there any restrictions for x on the derivative that would make, so if the derivative was undefined, like if it was like a vertical line, that would represent some kind of asymptote on the original function, right? Because we don't have the original function here. We just have the derivative. So any value for a derivative is okay except for when it's undefined. So do we have any restrictions here between 0 and 2? Now there's no denominator, there's no square roots, right? It's like there's no absolute value signs. So that's a good indication that, you know what, probably there's no restrictions. And if you can find an x that gives you that you can't. So we should be good, okay? So satisfy the mean value. We know that it's differentiable and continuous. Okay, no problems between 0 and 2. So what we do know, though, is we're trying to find an x value that makes this derivative equal to what? 0. Right. So, oops, let's see, what am I doing? Cos pi x equals 0. Okay, so are there x values? Well, remember what we do here with this kind of thing. Whoops, come on now. What we do is we take each factor individually, and we say that because of the zero product principle, that if this was equal to 0 or this was equal to 0, then we would have a true statement there. So you're going to let x equal, so it's going to be -1, right? Okay. Now, -1, oh, look at our interval. Okay, that's no good. So x equals -1 does not bother us. See? Because it's not in the interval, so that's not an option. But what about cos? Okay, so cos of pi x, or x pi, equals 0. All right, so here's where you got to remember your unit circle. Okay? 1, 0, so cos is 1 at 0. Cos is 0 at pi over 2, right? At pi, or 90 degrees, so that's where cos is equal to 0. So how do we make this equal to pi over 2?
I'm sorry, can I just do a manual for 30 seconds?
Sure.
Sorry.
No problem. So what does x have to be in order for pi x to be pi over 2?
1 over 2.
Yeah, 1 over 2, you see that? Okay? So what x value makes this factor equal 0? Well, x equals 1/2 for sure. Now 1/2 would be about here. Is there another value between 0 and 2? Or is this the only one? Well, where else is cos 0? It's over here at cos of 3 pi over 2 equals 0, right? Because why? This is 0, 1, this point, and this is 0, -1. Does that make sense? You good? So where does pi times x equal 3 pi over 2? Cos pi times what is equal to, what do I substitute for x here to make it 3 pi over 2? Pi times 3 over 2. So x would equal 3 over 2 as well. Now, is this between 0 and 2? Sure it is. That's 1.5. So what we have is we have two possible values right here. X equals 1/2, x equals 3 over 2. The answer is C. So if you guessed C and you didn't really understand why, you probably would have been, you're going to be okay with this question.
I got stuck at the point where I made both of the things equal to.
So if you didn't like what I did here, my reasoning right here, then literally you could say, okay, I know that cos of pi over 2 equals 0. So this right here, pi x, I need pi x to equal pi over 2. How do I solve for x? Well, all you do is you divide both sides by pi. So x equals, this is pi over 1, flip and multiply, 1 over pi. Pi's cancel out, I'm left with 1 over 2. So you can just do it straight mathematically that way too. Well, pi over x, pi x also has to equal 3 pi over 2. That's what I need over here.
Oh,
So let's just divide both sides by pi,
that makes sense.
and x equals 3 over 2. So you got rid of the pi. So that's the more methodical way, if you don't like the way why I did it there. Alrighty?
And we don't have a unit circle for the exam.
You do not have a unit circle for the AP exam? No. Will you have to memorize that? Yes, at least the first quadrant. And again, I mentioned in Pre-Cal 30, you have to know the first quadrant of the unit circle. Yeah, that's easy to remember. Like 5 different things you have to remember. That's it. Okay, so here's your answer. C, or that x or whatever, is 1/2 and 3 over 2. So there's your answer there. Yeah, and just back to that unit circle. What you need to remember here is this. You need to remember your 0 and your pi over 2, right? So 0 degrees or pi over 2, 0 degrees or 0 radians. This is 90 degrees pi over 2 radians. And then there's 3 important angles that you need to memorize. So that's the 60 or pi over 3, right? The 45 or pi over 4, and the pi over 6, the 30 degrees. And the points are going to be this. This one's easy, root 2 over 2, right? They're the same. Now, here, this is the easy part. This one here, you see how that's approximately halfway between 0 and 1? That's 1, 0, 0, 1. So this is, the first coordinate is 1/2. The only other thing you got to remember is root 3 over 2. And this one is root 3 over 2 over and about 1/2 up, you see, 0 to 1. So this is root 3 over 2 and 1/2. It would literally take you, 17.5 seconds to jot that down somewhere on your paper if you want. And that's all you need to know, because minus negative pi over 6, right, is going to have these same values, except one of these is going to be negative, right? You're going to go over root 3 over 2 again, but you're going to go down 1/2 this time, and so on. And over here, they're negative and a positive. First one's negative, second one's positive, and negative, negative. So you can kind of like branch out from there, as long as you memorize the first quadrant. But yeah, it's one of those things you'll have to put some time into. Okay, final question on our AP exam exploration day here. Okay, go ahead and take a few moments. You've got an XY table of values there. And it says the above table gives you selected values. And remember, that's not all the values. It's selected values. So this is what you know for sure. You don't know anything in between. But you know it's a twice differentiable function, so therefore it's going to be continuous and differentiable. We're okay with that. So which of the following must be true again? And yes, if you think about an average of 2 to 3 minutes for each multiple choice, they're going to give you 4 or 5 different options that you kind of got to think through. So your time can be eaten up pretty quick. So run through this. Go ahead and see what you can do. Take a few minutes to do this one. Okay, so let's work through this one here a little bit. Now, I've graphed some of the points here just on the side. Let me just bring those over so we can get all this on the same screen. All right. Oh, it's frozen still, sorry. All right, so we have a table of values. Here's the points plotted real quick. Okay, now they're not to scale, it's not perfect, but they appear to be increasing. So the x value increases, and so does the y value, increases the whole time. Okay, so A, let's think about A first. A has no critical points on the interval -1 to 5. Well, critical points talk about an asymptote, which we have no idea in between these points what happens. So it could have an asymptote, could also have a local max or min, looks like, right? So this graph could go something like this, and then it could go like this and back up. So we don't know that. So it's not this one. This does not have to be true. Okay. I'm going to skip around a little bit. What about E? The graph has no points of inflection. Well, again, we don't know that for sure because we could be concave up here, could be concave down here, could be concave up here. So it could have points of inflection. So that we do not know for sure. Okay. C. F prime is greater than 0 for all values on the interval. Well, again, do we know, does it say that it's increasing? Nope. So it could go like this, down, back up, and that would be, right? So that's no good. And this one, second derivative, is negative for all values of x. Could we have a portion of this graph that is concave up? And yeah, we could. We could have this portion that I've drawn, this portion that I've drawn. So that's not it either. Let's take a look at B. F prime is equal to 8 for some value on -1 to 5. Well, if we take a look at the total distance between -30 and 18, that's 48, right? So 18 minus -30 is 48. What's 5 minus -1? That's 6. So it appears that our secant line slope here is 8. Wow. MVT says that at some point, x on the interval, there has to be a point where the derivative is also equal to 8. So according to MVT, looks like B should be your answer. And there it is. Yeah, mean value theorem. The average rate of change is 8. Therefore, that has to equal some point C in the interval. Okay?
I found like the slopes for like all the points and they're all positive.
Yeah, okay. So you found the slopes between each successive point. They're all positive. Yeah, true. So if I drew this, but because the averages, like what you're doing is you're calculating though only an average between 2 points, right? Which doesn't really tell us what happens in between. So could you say that whatever this slope is between the first 2 points, that there must be some value in here that has the same slope? Yeah, we could say that. Totally. You know what I mean? Like if this slope, what's this slope? 28, a slope of 28. So there would be some, I mean, no matter what this graph looks like, the graph could look like this, you know, whoop, and there would be a 28 there, or it could be, you know, something like this. Whoop, well, there'd be a 28 here and a 28 here, whatever. Do you know what I mean? Like, yes. But finding the slopes of each section doesn't really help us too much because they're talking about the entire interval from -1 to 5. So yeah, you'd want to take this point and find the slope. All right, so you're going to recognize an MVT question on the AP exam, correct? Right on, so we can check MVT off our list, that we know what those questions are going to look like. Awesome. I think we only have 75 other boxes to tick, so that's good. 1 down, 75 to go. All right, good job.